welcome back to Josh Does Math. In this video, we're going to be doing a calculus problem that involves position and velocity and taking the derivative of position to get velocity. So let's jump into it. Find v of t if s of t is equal to 2t squared plus 28t minus 6. Also find the times when the velocity is 0 so that the point is momentarily at rest, and the times when the point is moving to the right. So we're given position as a function of time. That's right here, s of t. Our goal is to find velocity as a function of time. And we know that velocity as a function of time is equal to the derivative of position with respect to time. So we just need to take the derivative of that position function that we're given up there. So ds of t dt is equal to, and how do we take the derivative of this function? Well, you can see that it's some kind of a polynomial, so we're going to be using the power rule for derivatives. The power rule says power out front, one smaller on the power. So I'm just going to do that to each of the terms here. So power out front, one smaller on the power, plus power out front, it's one smaller on the power, and the last term, negative 6, is a constant, so the derivative of that is 0. And we can simplify this as 4t plus 28. And this is equal to velocity as a function of time. So now we're supposed to find the times when the velocity is 0 so that the point is momentarily at rest. So we're just going to say velocity is 0. And let's find the times for which that is the case. Okay, so we subtract 28 from each side. And we're going to divide by 4 on each side. So we end up getting t is equal to negative 7. So this is the value that satisfies the condition that we put on the equation, with velocity being 0. However, t equals negative 7 doesn't necessarily make sense in this scenario, because you imagine that we would, whatever problem this is that this equation deals with, you would probably start at t equals 0 and only move through positive numbers as far as t is concerned. So the fact that we're getting a negative t doesn't really make sense, but maybe for some reason this is time after something happens. So if you have a negative time, it just means it occurred before the reference point of t equals 0. So this may or may not be a solution for t that actually makes sense in the context of the problem. But since we're not given the problem, we can't say whether that's the case or not. And now we're supposed to look at the times when the point is moving to the right. So if the point is moving to the right, that means it has a positive velocity. So we're going to say that v of t is greater than 0. And we know that v of t is given by this equation up here. So you just plug that in for v of t. And we get this. And now our goal is to solve for t, so you're going to subtract 28 from each side. So 4t is greater than negative 28, and you're going to divide by 4. So you end up getting t is greater than negative 7. So whenever you're at some point in time past negative 7, this point is going to be moving to the right. So that's how you do a problem like this that involves position and velocity in calculus. Thanks for watching.